I'm Binit Chaudhary and I am here with another tutorial. In this tutorial, we are going to discuss what is quick sort and why it is preferable to other sorting algorithms and why we use it and what's the advantage of using quick sort. So let's start without wasting any time. Here I have prepared some slides for your better understanding. So let's start. Quick sort. So what is quick sort? So we can define it on this slide. So it's the main idea of quick sort. Quick sort is a divide and conquer algorithm. As you've seen divide and conquer algorithm, this word is also in the merge sort. So we can conclude on some steps that quick sort is like merge sort. No, at one point it is not, but at divide and conquer concept they both are same. They divide the arrays into two subarrays and then conquer it. In the quick sort we also do it. We divide an array and then conquer it, and it is an important rule of quick sort. So in the first step, that is divide step. So basically this step divides the arrays into many sub arrays. So what this step it is? Choose an element P known as pivot. So I was talking the difference between the merge and the quick sort. So the one point different is this pivot point. There is no such point in merge sort, but pivot is in quick sort. So what this pivot point do? It distributes the array into two subarrays. Mean we can say that it partitions the array into two arrays. In which partition? Items that are smaller than the P and the items that are greater than or equal to me. So it means that the pivot divides the array into smaller and the larger element, and where these smaller and the greater items places we could discuss it later. So by this step and by the help of pivot point, the quick sort divides the array into subarrays and conquer it. In comparison, merge sort spend most of the time in conquer step but very little time in divide step. So this is the difference. So what there is an example of quick sort. Here we have an array of 27, 38, 12, 39, 27 and 16. So as you see in this array, I have taken 27 as a pivot. Means there is no one hard and crash rule of selecting pivot always at a first index. You can choose it randomly. The pivot point can be the last one. The pivot point can be median or any other point. So, but the basic one is this: the pivot point divides the array into two sub arrays, the lesser one array and the greater one array, and where it places we can see after. So the pivot divides this one array into these two arrays and then sort it. So basically, as I said, the elements that are on the left side of pivot are smaller. So the pivot divides the array into two sub arrays. The left sub array is less one and the right sub array is the bigger one element. So the lesser elements are on the right side of the pivot and the bigger elements are on the right side of the pivots, and by this we can sort or array. So here comes the method of the pseudocode, or I can say the important algorithm of quick sort. So the first and important condition है if low is less than high. low is less than high. Any point, I think I here takes 27 as a low and 16 as a high. So here in condition I applies if low is less than high. If it true, it goes to the inner condition where Q partition A, low, high. So A is the basically array, low is the low point and high is the higher point. And this is the quicksort, which call its on method with array low point and -1 quicksort A, Q plus 1 and high. So in the next step on this point partition, it calls the method partition, and it is the most important method of all the quick sort algorithm, because in this method all the main functionalities are being done. The arrays sorted, the rearranging and the swapping all are in this one method. So in partition method, here I define an array, a low point and the high point. In the next step I have taken pivot, defined pivot. We have discussed pivot, a particular point that divides the array into two sub-arrays, smaller on the left and right elements that are bigger on the right side. Is A of high. We have declared a high element as pivot. So I is equal to low minus 1. Here I is an element in an array, and we assign that I is equal to low minus 1. In the next step we have created a loop, a for loop, in which we said that j is equal to low to j less than equal to high minus 1, means that j is low and it will travel till to j less than equal to high minus 1. If this one condition becomes true, we can move toward the inner loop, but if condition is false, we will do that step that we will explain later. But if we are talking that if this condition becomes true, so we move to the inner statement. Do if A of j is less than pivot. A of j, as we discussed, that j is equal to low, so here the value of j will be the low value. And if it is less than pivot, means if it is true that A of j is less than pivot, then what we will do, we will increment the value of I, and I is equal to I plus 1. Here I is equal to low minus 1, and here in the loop, if the condition becomes right, we will increment the value of I is equal to I plus 1, and also exchange A of I and A of j, means we do swapping here. So if we talk here about the true condition, so what if this condition becomes false? If this one condition false, the value of j will be incrementing. J increments, means if we go back to some point, if here I low, if I think that 27 is at low index, 0 index, so if this whole condition becomes wrong, so the value of j increments, mean now j is equal to 1. So by this we will check all the condition till it becomes true. If this condition is not true, we will keep on incrementing the value of j. After this condition becomes true, we will get out of the loop and exchange I plus 1 with A of high, means we will exchange AI plus 1 with A of high that we have set it as pivot, the last element. So we will exchange this one with the pivot value, and it will return I plus 1. So basically by this algorithm, it is much easier to understand the working or the main working functionality of the quicksort. So now we will move toward more convincing side. This one here, it is in the array. We will convert the array into a form of heap, a tree, so we can better understand. Here I have an array of 10, 80, 30, 90, 40, 50 and 70. In this array I have taken 70 as a pivot. So what it would do? So it would divide the array into two sub-arrays, means the values that are lesser than 7 are on the left sub-arrays, and the values that are greater than 70 are right sub-array. And here the values that are less than 70 are 10, 30, 40 and 50, and the values that are bigger than 70 is 80 and 90. The sub-arrays that we obtain in these subarrays, we also find a pivot point and do partition and divide it into further sub-arrays. So in this array 10, 30, 40 and 50, I have choose 50 as a pivot. So again, pivot will divide it into two sub-arrays, lesser elements that are less than 50, 10, 30 and 40 on the left side, and hence there are no element that is greater than 50, so null on the right side. If we talk about the right sub-array 90 and 80, I have taken 80 as a pivot point. So what will this 80 do? It will divide also in two sub-arrays. At 80 is pivot, so there is no less value than 80, then it returns null on the left side and the 90 on the right side. So in this also subarray 10, 30 and 40, I have choose 40 as a pivot point. So what this 40 will do? It will also divide it into two subarrays. The values that are less than 40 will be on the left subarray, and hence there is no value that is greater than 40, that is the pivot point, so it will be null. Further, we have 4, 10 and 30. In this case I have taken 30 as a pivot point. So this pivot point gives us two subarrays. In one 10, that is less than pivot, so it is on the left side, hence there is no value that is greater than 30, so it is null. So by tree it is more understandable by the concept of quick sort. Now we move toward the analysis of quick sort. We will understand its worst, best and average case scenarios. So next is analysis of quick sort. How we can analyze our quick sort? Running time of quick sort depend on whether partition is balanced or unbalanced. This one step is very important, that when we are taken out the running time of quick sort, so it mainly depends on the partition, and it is very important that partition should be balanced, and it is only balanced by choosing a rightful pivot at the rightful position. So if we move toward the worst case scenario, as you know that in worst case scenario we always take sorted array. So by this algorithm we have a sorted array like 1, 2, 3, 4, 5, 6 and 7. So we'll apply worst case scenario on this one array. So if I choose 1 as pivot and it is n times of array, so what will it do? It gives us one pivot, so there is no less elements than 1, so and the greater values than 1 are 2, 3, 4, 5, 6, 7, so here they are. In the next step I will take 2 as a pivot, and the pivot point is here. No lesser values are, but there are many values that are greater than the pivot, and they are 3, 4, 5, 6, 7, and we have gained n minus 2. At if we choose 3, then I have n minus 2. If I choose 4, then I have n minus 3. So on the next step, we see how it works. In the worst case scenario, we sum up the time of sorting left sub array plus time to sort right sub array and partitioning time. So here all the manipulation of that summing up time, and it is here t n minus 1 plus sum of natural series, and we know that the sum of natural series is n into n plus 1 divided by 2, plus it gives us the one that is constant, but we consider this one figure, and by this it is n square by 2 plus n by 2. So we always consider the big one value, so we take n square. So in this case, the worst case scenario of the quick sort is big O of n square. So now the worst case is cleared, so we will move toward the best case scenario. So here, as we said, best case scenario of the quick sort. In the best case scenario, we always take an unsorted array. Means that before applying the algorithm, we can say that an unordered array, we will apply best case on an unordered array. So I have an array of 7, 9, 2, 6, 3, 10 and 1. So if I take 6 as pivot, so what will it do? So this 6 divides the array into 2 sub-arrays. So the elements that are less than the pivot point, that is 6, are on the left side. These are 3, 1 and 2. The elements that are greater than the pivot point are on the right side. So the n times of array is divided into 2 sub-arrays of n by 2 and n by 2. Pivot divides arrays into 2 equal sub-arrays of size n by 2. It is the same talk as we discussed earlier. So in the next slide, we briefly discuss the best case scenario by implementing it. So here an example of array, as you say, array of k. This one is the pivot point, and this is the left sub-array, and this is the right partition. So these left and right partition arrays, sub-arrays should be nearly equal. So given time to sort array of size n, this is an array of size n, 2t n by 2, this is the time of sorting 2 sub-arrays, means the summing of t n by 2 plus t n by 2 gain us 2t n by 2 plus n minus 1, and this n minus 1 is the cost of partitioning sub-arrays of size minus 1. Here you can say that if I take only this t to n by 2, means if I take array of n time, and then I take array of n by 2 times, so I can say that it will become 4t n by 4 plus n by 1. So next step, we can say that we can write 2k is equal to n, and by manipulating all the procedure, we gain the value of k is equal to log n by applying the log rule. So this log n and putting it into the equation, so we get the best case running time of the quick sort, that is theta n log n. So it is clear that the best case scenario or the best case running time of the quick sort is theta n log n. So we will move toward now the average case scenario, and that is much similar to the best case scenario. So it is same that if k is pivot and left partitioning of size k minus 1, right partitioning of size n minus k. So here is the summing up of the two sub arrays, and now in this we have procedure of rearranging array, so we can sort it. So basically you can see that the average running time of quicksort after all the iteration method, substitution method, that is big theta and log n, as same as that of best case. So here we have completed implementation or understanding of quicksort by our slides, that is theoretically, but we will now practically implement it. So it is understood that how by using the algorithm, how by using the procedure or understandings of the quicksort, we can write up a code of the quicksort. So that will be much understandable and much easier to know how the quicksort works and how it sorts the array. So I will go to the my NetBeans, and here I create a new project, name as quick sort, better to be quick sort 3. Okay, so finish, and here we have created our project name with quick sort 3. In this class of quick sort 3, a method sort, we will create a method sort that is very much important in building our quick sort concept, because most of the operations are being performed from this one method, and it is very important. So we will start writing our code and implementing this sort. So let's start. So here I will create method public void sort, and in this I will define an array int low value, int high point in an array, and here I will write another condition if low is less than high. If this one condition is true, what will we do? We will do that, and where pi I write is the partitioning index, and it is equal to the partition array low high. Here so here by this variable we call a partitioning method, so we'll write another method that is called partition, and this method is very much important because it will partition our array into subarrays and then sort it. So public void partition, and in this partition define array and array per int low, int high. So by writing int pi, that is the partitioning index, is equal to partition array comma low comma high. So it's calling the method that is partition by defining the array into the low point and the high point. So what we do in this method, on the first step we'll define int pivot. So we discussed earlier what's the pivot point, the point that divides the array into two sub arrays, and on the left side the less elements, or on the right side are greater elements. So here int pivot is equal to array of high. So we have declared the higher element as pivot. The next step, int I is equal to low minus 1. So here what we did, I is equal to low minus 1. Basically this one code is much similar to the algorithm of the quicksort, so it is very much easier to understand the basic concept of the quicksort. In the next step we will create a for loop, and what will this loop do? In this I will declare a variable j that is equal to the low, and j is less than equal to high, and j plus plus means j increments. If this condition true, we will move to the inner condition, that is if array of j is less than pivot. So what is it? If pivot, here we have pivot taken as higher point, so array of j is low. So if array of j is less than pivot, if this condition true, so what we will do, we will move to further inner condition. In this condition the value of I increments, I plus 1 plus plus here I is equal to low minus 1, and here we increment the value of I. In the next step we have created an variable in temp and equal it to the array of I. So array of I is equal to array of j, and array of j is equal to temp. So what basically is done in this step is swapping. We have swap array of I and array of j. So this is the procedure if this one condition is true, but what if this condition becomes wrong? So there is a point. If this condition is true, we will move to the inner condition and implement this swapping, but if this condition is false, we will move out of the loop, and here I again declare a variable temp that is equal to array of I plus 1, and this array of I plus 1 is equal to array of high. And in the next step array of high equals to temp, and in the next it returns I plus 1. So this is the procedure after this condition is executed and this one will execute after that, and this will swap array of I plus 1 and array of high. As you notice that I have declared array of high as pivot, so basically I am swapping array of I plus 1 with the pivot point, or say the higher point. So this process is completed. Now I have first written the sort method. In this method, we check the condition if low is less than high. If it is true, move to the inner condition where partition index is equal to partition array of low and high. So this is basically calling the partition method, and in this method all the partitioning has been done and some of the swapping is also done. So in the next, I again create a method public void print array. Here I will define and so I will make it static. So in this we will print an array, and by how we will do this. First I define another variable that is n and equal is to array dot length. So basically this variable is used as the length of array. In the next step we will create a for loop. In this loop I will define a variable int I is equal to 0, I is less than n, and I increments. If this condition is true, we will print out print ln. We will print the values, the sorted values, and plus here also prints the space. And then next, system dot out dot print ln, and it is for the next time, so it is much easier to see the sorted array. So we also created the print array method for printing array on the screen. Now in the next, we goes to the main, and here I will create an array with elements 10, 7, 8, 9, 1 and 5. So we have created an array. Now create a variable n is equal to array total, and it will take the length of array. Next step is to create the objective object of this one class, that is quick sort 3 a, and a is the object. New quick sort 3, and by the help of this object I will call the sort method n, and here the low value will be 0 and higher will be n minus 1. In the next, I would like to print in the output string as print and sorting array. And in the last and the final step, I will call print a method for printing array on this screen. So as you will see in the whole code, I will discuss and repeat all the procedure. The first thing I did it, I created a sort method, and then I say this one is very much important, and it's through this method all the functionalities and the partition has been performed in this code. And in this sort, I first created a condition if low is less than high. Then we'll move to the inner condition. Here partitioning index is equal to partition array of low and high. This one calls the method partition, and in this method the array is partitioned and swapped and then sorted. So first in this method I have declared pivot as the higher value, and int I is equal to low minus 1, a for condition in which j is equal to low to j less than equal to high, and increment j value. And if the condition is true, move to the inner condition, if condition, in which I write as array of j is less than pivot. If the value low value is less than pivot, then perform this one functionality, that means that swap array of I and array of j. And after that, swap array of I plus 1 and array of high, means array of high means pivot. So swap array I plus 1 with a pivot point, and after that return I plus 1. In the next step, I created the method of print array. By this method we can print array. We print sorted array elements on the screen, and in the last main, with the help of the object A created for the class quicksort3, I call sort for sorting an array and print, and call the print array method for printing array. Now if I run this one procedure, you can see a sorted element here, the sorting array 1 5 7 8 9 10. So basically what we all did is, today tutorial we have discussed quick sorts much largely and deeply. We know this analysis, we have know its divide and conquer rule, we know how to select the pivot point and what's the importance of the pivot point in selection, we know about partition, and we also see its best, average and worst case scenario, and we also implement it here, so it is much easier and understandable to us right now. So I may say that you may be very much understandable by all this procedure. So thank you.